Welcome to this video on Year 2 Pure Chapter 7 Prep Practice. That's on trig identities and modeling, I think. So question 1, you need to know all the identities that are in the textbook reviews, notes, etc. And the first one here is sine of A plus B, which is sine A cos B plus cos A sine B. You don't need to know the proof of this, but it's nice if you do. Tan of A minus B is what you might expect if you got it wrong, which is tan A minus tan B, but you have to divide by 1 plus tan A tan B. And in cos 2 theta, there are 3 forms of cos 2 theta you need to know. The most easy from cos of A plus B is cos squared theta minus sine squared theta. Moving on to question 2, this is pretty much an extension of first year. We're expected to be able to work out from sine, cos, or tan any of the other trig ratios by looking at which quadrant the triangle from the definition can be created. But in year 2, we're expected to be able to do that and apply it to identities. So question 2a, given that cos of A is a half, and A is acute, so we're in quadrant 1, so quadrant 1, 2, 3, and 4. Find the exact value of cos of pi over 6 minus A. Well, cos of pi over 6 minus A is going to be cos of pi over 6 cos of A plus sine of pi over 6 sine of A. You should know that what cos of pi over 6 is. That's cos of 30 degrees, which is root 3 over 2. And sine of pi over 6, which is sine of 30, is a half. So what we really need to do is to work out what sine of A is, because we know that cos of A is a half. So creating a triangle in the quadrant 1 with cosine being a half can be done by making the x-coordinate 1 and the radius 2, and then by Pythagoras working out the y-coordinate is root 3, and then for sine being the y-coordinate divided by the radius is root 3 over 2. And then substituting those values in, we can get that cos of pi over 6 minus A is going to be this expression here, which simplified is root 3 over 2. Similarly for B, we have sine of A is 5 over 13, where A is obtuse, so in quadrant 2. Cos of B is minus 7 over 25, where B is reflex. That means it's in quadrant 3 or 4. Because cosine is not negative in quadrant 4, we must be in quadrant 3. We create a triangle for which sine is 5/13 by making the y-coordinate 5 and the radius 13, and work out the x-coordinate as being minus 12 by Pythagoras. We can get 12 from Pythagoras, and then because it's in quadrant 2, the x-coordinate must be minus 12. And likewise for B, we're in quadrant 3. Tan is 24 over 7, so the y-coordinate and the x-coordinate must be 24 and 7, but because we're in quadrant 3, they're both negative, just minus 24 and minus 7. And then by Pythagoras, if these lengths are 7 and 24, and the radius is 25. From that, we can get sine, cos, and tan of A and B as we need. And therefore tan of A minus B, which is tan of A minus tan of B over 1 plus tan A tan B. We substitute in for tan A being minus 5 over 12, tan B being 24 over 7, and so on. And we can get this expression, which simplified gives us our answer. Okay, so that's question 2. Question 3 is a major new technique in year 2. I'll say more about this in class because there's quite a lot to say about it. But let's look at this question and let's give you the minimum that you need to answer it. So we want to write down 5 sine x plus 5 root 3 cos x in the form r sine x plus alpha. It's always possible to do this. So as long as the phase of sine x and cos x are the same, sorry, not the phase, the frequency. In other words, if it's x here and x there, that's fine, or 2x here and 2x there, that's fine. They have to have the same frequency, they have to have the same multiple in front of x. We can always write it in this kind of way. How do we do that? Well, what we do is we expand out r sine x plus alpha to get r sine x cos alpha, and then plus r cos x sine alpha by expanding out sine of x plus alpha. And then what we do is we say, well, that has to be the same as 5 sine x plus 5 root 3 cos x. And a bit like with polynomials, if they're identical, then they have to be the same polynomial. In other words, the coefficient of x squared must be the same on both sides, the coefficient of x must be the same on both sides, and the constant must be the same on both sides. Likewise with sine and cos, if we have a multiple of sine x plus a multiple of cos x, that can only be identical to the same multiple of sine x plus the same multiple of cos x. And therefore we can compare coefficients of sine x and cos x on both sides of this identity. So doing that, on the left-hand side, the coefficient of sine x is r cos alpha. Okay, remembering sine x is the variable and r cos alpha is a constant. On the left-hand side, it must be the same as the coefficient of sine x on the right-hand side, which is 5. Similarly for cosine, the coefficient of cos of x on the left-hand side is r sine alpha, and on the right-hand side, the coefficient of cos x is 5 root 3. And then we solve these two equations simultaneously. The easiest is to get r by either squaring these two and adding together, or by creating a right angle triangle, but it's always the case that r is the sum of the squares of each of the two right-hand sides. And so in this case, it's 10. And then by dividing the first equation by the second equation, the r's cancel. Sine divided by cos because it's tan. 5 root 3 divided by 5 is root 3. And so we get tan of alpha is root 3. Inverse tan of that gives us alpha is pi over 3 or 60 degrees. And that then means we can write this expression in this form. This helps us to be able to sketch it, work with it, but amongst other things, it helps us with part A below to solve this equation, where the first step is to replace 5 sin x plus 5 root 3 cos x by 10 sine of x plus 60. And then by dividing by 10, we end up with a equation of the type we could solve last year, where we do inverse of minus a half, get the principal value for x plus 60, the secondary value for x plus 60, lots of values for x plus 60, and then subtract 60 from each of them, and we can get the correct solutions in the interval that's required. And then for part B, a very common question, we want to find the minimum and maximum of the expression 13 plus this expression here, which should look familiar. If we replace that expression by 10 sine of x plus 60, we get that the whole thing is 13 plus 10 sine of x plus 60. And if we then want to consider what the maximum of this is, well, the maximum of sine is 1. So the maximum of 13 plus 10 times sine is 13 plus 10, which is 23. And the minimum occurs when sine is minus 1. So we have 13 minus 10, which is 3. I hope that's easily very typical of exam questions you might well get. Last question, question 4, is proving an identity. Remember, the format for a proof is that you start with the one side and obtain the other, or you start with one side, get something simple, start with the other side, get the same simple thing, and then deduce that they're identical. Do not work on both sides simultaneously as if it were an equation to solve. So here, if you know that cos of 2x has 3 forms, and the form that I'm choosing here is 2 cos squared x minus 1, we substitute that in. Sine of 2x can be replaced by 2 sin x cos x, and we get this expression here where we can see the coses cancel. We get cos of a sine, which is 1 over tan, which is cot x. May seem easy when it's done, but actually quite difficult to work with identities in some cases. So practice doing these kind of questions. Okay, I hope that was useful.